Now we're going to multiply and divide rational expressions. It's very similar to when we simplified rational expressions, except we just have multiple fractions instead of a single fraction. First of all, if it's division, the first thing you're going to do is change it to multiplication. So this particular example below is not division, but the next example, number 2, will be. So if division, change it to multiplying by the reciprocal. Then completely factor out the numerators and denominators. So let's factor the numerators and denominators on the next step. You can use any of the methods of factoring that you have learned so far, whether it's pulling out a GCF or factoring by grouping or trial and error kind of factoring, or difference of squares, difference of cubes, sum of cubes, all the different kind of factoring methods that we used you can use here. So I've factored all these. Now we're looking for, in step 3, dividing out any matching factors. And you can look at any top with any bottom. It doesn't have to be in the same fraction. It can be in the other fraction, any top with any bottom. So I see that there is an x plus 3 here and an x plus 3 here, so we divide those out of top and bottom, and they basically just give you ones when you divide them out of top and bottom, but the ones just end up going away, so you can just think of them as canceling out. Then we have a x minus 5 here and an x minus 5 here, and that also causes ones, which just makes them end up going away. And then you don't have to be in diagonal fractions from each other. You can even be in the same fraction. So x plus 5 and x plus 5 are in the same fraction. Any top can cancel with any bottom. Then if we put what's left, across the top we have an x minus 2 times a bunch of ones, which don't really have any change to them as far as x minus 2 times 1 times 1 times 1 is just going to be x minus 2, and that's why we just kind of end up dropping off the ones. And then along the bottom we just have 1 times 1 times 1, which is 1, and anything over 1 is just itself. So this whole thing reduces to just an x minus 2. Now the last step, so we just divided out any matching factors, any top with any bottom. And it's very important that we write this step, and they'll usually remind you in the directions to write this step, but state the restrictions on the domain. Now we don't just want to look at the final answer denominator, but we want to look at any factor that was ever in a denominator anywhere in the problem. And so we have to say that if x was equal to 5, it would make this denominator equal to 0, and you never want 0 in the denominator. So x cannot equal 5, and then for this one, this is also in the denominator, x cannot equal negative 5, and finally this denominator here, x cannot equal negative 3, because any of these numbers would cause a denominator somewhere along the way to be 0, and any 0 in a denominator makes that whole thing undefined. So the answer to the simplification is that x minus 2 is the simplified version of this problem, of this answer, but we also have to state that x is not allowed to equal negative 3, 5, or negative 5, and then this x minus 2 will be true. The first thing you always want to look for is if it's a division problem, before you ever get started factoring, you want to change division of a fraction to multiplying by the reciprocal, which just means to flip just the second fraction, not the first fraction. Dividing by a fraction is the same as multiplying by the reciprocal. The second thing you want to do is to factor any numerator and any denominator that you have, and including things like factoring out the GCF, and I notice that this one does have some factoring out the GCF. This one has a 3 in common, so that's 2 minus x, and we'll replace it with its original. This one they all have a 6 in common, so we're going to rewrite that as x squared plus 3x minus 10. I'm going to replace that with its original. And then we can do some more factoring on the next step. And sometimes I like to do some of the factoring just right on top of each one or right underneath each one. This one has factors of x plus 1 and x plus 1. This one is a difference of squares, and it's an x minus 1, x plus 1. So it looks like we can do one more thing. We can factor this some more. So I'm going to cross off this and write what it is in its further factored form. We have a 2 and a 5, and to get this positive 3x, we need the 5 to be positive and the 2 to be negative. One thing that we talked about in the simplifying rational expressions section is if you have something like 2 minus x, and down here you have something like x minus 2, and they're backwards across the subtraction sign, you can't cross those out until you factor out a negative 1, and then you can switch it to an x minus 2. And that gets combined with the 3 that was already out there, so we'll rewrite this on the next step. So you can switch around a subtraction sign as long as you factor out a negative 1, then you can flip-flop them and call it x minus 2. And then you'll be able to cancel it with the other x minus 2. So crossing off all the previous versions, looking at what we have left in each numerator and each denominator in its final factored form, then just rewriting it here. This is what we have, and we can start reducing or dividing out common factors. So we have an x minus 2 and an x minus 2. We have an x plus 1 and an x plus 1. And that is all the binomial factors that will cancel, but we also have a 3 here and a 6 here. We can divide both of those by 3, and this becomes a 1. And this becomes a 2, but don't forget there was a negative out here, so that'll be a negative 1. So what we have left is negative 1 times x minus 1 over, then what we have left on the bottom is a 2, and then an x plus 1, and an x plus 5. The only thing that you could possibly do differently is sometimes people will distribute this negative through, and you'll end up, and then they'll switch it to where this becomes a 1 minus x on the top. It's just a little simpler than writing what was there originally. So you could rewrite the top as 1 minus x. It's kind of the reverse of the rule that we did before, where we factored out a negative 1. Well, you can put back in the negative 1, divide it, multiply it back in, and switch the terms, and you get 1 minus x. So that means the same thing. You could have either one of these numerators, but we'll just leave it like this, and that's in its factored form, and just know that you could have changed the top if needed. And finally, step 4 in this process was to state the restrictions on the domain. And one of the things I said was you need to look at every denominator that ever was, and that means that all the way back in this step, at the very beginning, x squared minus 1 was in the denominator at one time, and so that means that these two factors cannot equal 0, because that would cause that denominator above to be 0, and that would be a bad thing. So even though it ended up in the numerator, it was in the denominator at one time, and so we have to take those two factors into consideration. We also have to take these two factors into consideration because they're in the denominator, and we have to take these two factors into consideration because they're in a denominator. And so the easy one to forget about is the one that's here, because it is in the numerator all the way down to this step, but it was originally in a denominator, so you can't have it equaling 0 either. So it turns out that this one, this one, and this one cannot all equal 0, but neither can either of the ones in the numerator because they used to be in the denominator. So that causes several things that x is not allowed to be. X cannot be anything that would make any one of these factors equal to 0. So x cannot equal this, which would be 1, this one, which would be -1, this one, which would be -1, so we don't have to write it again. This one would be -1, we don't have to write it again. This one would be, if x is 2, that would become a 0. And this one, if x was -5, that would cause that factor to equal 0, which would cause the denominator to equal 0. Now, one thing that you don't have to worry about is if this is a 6, 6 can never become 0. It doesn't matter what x is, and so you don't have to worry about getting another restriction on that one. But if that was a 6x, just for future reference, if that was a 6x, there is a way to make 6x equal to 0, and that would be if x was equal to 0. So you'd also have to say x cannot equal 0. But since there is no x with the 6, we don't say that. And so these are our 4 restrictions to our domain. And this is the answer of our simplification. So you kind of need to say both of those things somewhere in the answer.